Sharks have been around for a long time. They have technically been around longer than true trees have, originating in the Ordovician period, while the green woody giants emerged in the Middle Devonian. Unfortunately, their cartilaginous skeletons decay to mostly nothing when they die, under most circumstances. Only hard parts get preserved. This has left us with a slew of tantalizing bits and pieces of some of the weirdest things to slide through the water. One of those mysterious enigmas of the cartilaginous fish fossil record is the porcupine eel shark, Listracanthus. Sharks and their closest relatives, informally called the cartilaginous fish and scientifically referred to as chondrichthyans, are not super closely related to all the other fish, enough to the point that the term fish shouldn't really apply to them. Fish is not a scientific term anymore. It's an informal term to refer to things that are fish-like. In other words, not everything that we call a fish all belong to one big group of related animals. Lobe-finned fish, for example, are our cousins. We share a common ancestor with them. The ray-finned fish are a whole nother enormous group of critters. There are also the cyclostomes, or the cyclostomatans, the living jawless fish. They form their own group. There are plenty more extinct groups like the placoderms, ostracoderms, conodonts, and more. Unfortunately, aside from the largely boneless, notochord-having jawless fish, the sharks are the only group that almost never fossilize well. They usually never leave behind anything aside from their teeth, scales, or spines. Sometimes though, under awfully specific environmental conditions, their soft tissue can preserve. Under even better conditions, their cartilage can also preserve. These are exceedingly rare and seem to happen more often in more recent critters, though that may also be a result of the fossil record's fickle bias. This all means that if you want to study sharks and their relatives, you have to become familiar with the worst fossils imaginable. You get piddly squat when compared to the bone-brandishing, awfully great reptiles. However, one thing that shark paleontologists have over dinosaur paleontologists is that the teeth of sharks and their relatives are a lot more diagnostic than dinosaurs. By that I mean, one can use the minute differences in the sculpturing of shark teeth to understand how they evolved and what kind of critter it was and where it places on its family tree. You can tell them apart by their teeth. You cannot do this with dinosaurs because most groups kept the same type of tooth. They usually changed in size or proportions, but not in the minute details. The same characteristics of shark teeth are what make mammal teeth so special. It's why you will almost always find that there is more than one species per fossil mammal genus, while dinosaurs are stuck with just one. The bias of time and the fossil record also have a lot to do with all of this. Sometimes, though, teeth are not the major identifier of a fossil cartilaginous fish. Sharks have scales, but not like the scales of any other group of animals that have scales. They don't really count as scales because they are composed of the same material that make up their teeth. That's why they get a special term, dermal denticles. Fun fact, fish scales may have evolved from teeth, with sharks keeping their scales more tooth-like than other water-dwelling vertebrates. One of the most interesting mysteries of the fossil shark record is known primarily from scales, and also some hard spines. This is the porcupine eel shark, Listracanthus. History of discovery. The long, storied, but ultimately disappointing history of Listracanthus begins all the way back in the late 1800s. Two paleontologists were the first to describe and publish their findings about this mysterious slish slosher. John Strong Newberry was an American physician, geologist, and paleontologist who participated as a naturalist and surgeon on 3 expeditions to explore and survey the western United States. If you forgive the digression, during the Civil War, he served in the U.S. Sanitary Commission and was appointed Secretary of the Western Department of the Commission. After the war, he became Professor of Geology and Paleontology at Columbia University School of Mines. All in all, a rather accomplished dude. The other guy, Amos Henry Worthen, was an American geologist and paleontologist from Illinois, and the second state geologist of Illinois and the first curator of the Illinois State Museum. Worthen was a fellow of the American Association for the Advancements of Science and a member of the American Philosophical Society and the National Academy of Sciences. Listracanthus hystrix, 1870. Once they surveyed the western United States, they published a series of volumes on all the fossils. In their fourth volume, they described a bunch of spines and dermal denticles, unlike that of any other fish, cartilaginous or otherwise, living or extinct. The spines they found are small, gently arched, flattened, and thin. The sides are marked by numerous sharp longitudinal spines. The edges are set with many divergent, slender, acute teeth. Those on the convex margins are most numerous and largest. It's almost like a bristle or a brush or a feather, but made of hard dental material. The base of these spines is abruptly expanded and obliquely truncated. Newberry and Worthen noted that these spines were considerably unlike anything that had ever been described until then. The base is different from that of most defensive spines, as it's abruptly truncated and expanded, showing that it was set on the surface and did not deeply penetrate the integument. In this respect, these spines resemble those of Climatius, a genus of acanthodian or spiny shark from the early Devonian of Europe and North America, and may be considered modified scales or cranial scutes. They were probably attached by their broad bases to the body or head, serving perhaps both for ornament and defense. These fossils were, and I guess still are, quite common in the coal measures of Indiana and Illinois, but rarely seen in Ohio. In Indiana, these spines occurred so frequently with the dermal tubercles of Petrodus, a small shark-like animal, that they were generally supposed to belong to the same fish. So the pair decided to name the fossils Listracanthus hystrix. Since paleontologists during the 1800s rarely explained themselves in any great detail, the authors never explained where the name came from or what it means. The lister part of the name may either be Greek, meaning stripe, or Old High German for border. Either honestly work for the rest of the name, with acanthus meaning spined, and hystrix from ancient Greek meaning porcupine. So the stripe-spined porcupine or border-spined porcupine, I guess. Listracanthus hildrethi, 1875. In Part 2 of Volume 2 of the Report of the Geological Survey of Ohio, published in 1875, John Strong Newberry was back again to describe new fossils of Listracanthus that had been found in, you guessed it, Ohio. The fossils described here were spines of relatively large size, nearly 2 inches from the summit, curved and sharply carinated, carine slightly granular, convex side strongly squamose. Carinated refers to something that has a ridge or keel, and squamose refers to something that is scaly. About only a single specimen of this spine was recovered, and that lacked the basal portion. It was sufficient, however, to show that it was much broader, more curved, and more strongly and sharply marked than even the largest specimens of the first named species, so Newberry named it Listracanthus hildrethi, in honor of Dr. S.P. Hildreth, who originally found the fossil. Listracanthus bayrichi, 1879. German geologist and paleontologist Adolf von Koenen published a description of more Listracanthus spines as the new species Listracanthus bayrichi in 1879 in the Culm Fauna of Erborn, Yearbook of Mineralogy. But this volume is incredibly hard to find and almost definitely not translated, so we can largely ignore it for now, especially considering what eventually happens to most species named for the Listracanthus genus. Listracanthus wardi, 1891. In 1891, English paleontologist and world expert in fossil fish Arthur Smith Woodward published a magnum opus of sorts titled Catalogue of the Fossil Fishes in the British Museum Natural History Part 1, British Museum, Natural History, London. This thing was many volumes long, but most importantly, saw the description and naming of a new Listracanthus species, Listracanthus wardi. He then wrote about and described some new specimens in 1903. As he says, in his timely parlance,
The problematical fish spine, Listracanthus, has already been found in the English coal measures, but neither the specimens from this country nor the earlier discoveries elsewhere are sufficient to show the exact nature of the fossil, or even to determine its complete form. Two groups of remains of this spine, recently discovered by Mr. John Ward, FGS, in the middle coal measures of North Staffordshire, are therefore of much interest as tending towards a more satisfactory knowledge of its character.
The first group of remains Woodward discusses is one within a nodule. He stated that the nodule probably makes up the remains of a single individual, but it did not preserve any soft tissue and is just a bunch of scales or spines as per usual. The second group is portions of at least 70 irregularly scattered spines, with some intermingled smaller dermal tubercles. Most of the spines were broken, but Woodward provided a generalized or hypothetical reconstruction of the spine if it were complete. He notes that they are all encrusted with a thin film of pyrite, and their dark brown substance, presumably vasodentine, is so brittle that it is usually more or less flaked when uncovered by the hammer. Each spine is a thin, solid lamina, which seems to be bilaterally symmetrical, tapers a little towards the apex, and is slightly arched either backwards or forwards. The straight baseline is oblique with respect to the long axis of the spine, and its extent equals about 1/5 of the total height. The apex is not pointed, but comprises a little cluster of sharp denticles, which are partly formed by the ends of the lateral ridges, partly independent and intercalated. The ridges are very delicate and sharp throughout, quite smooth, of uniform thickness, and separated by comparatively wide, smooth interspaces. All this means that the spines are not usually entirely spine-shaped, but feathery. Woodward noted that,
"From the specimens, it is evident that Listracanthus is a strangely modified dermal denticle, occurring in considerable numbers on part at least of the head or trunk of the fish to which it belonged."
He went on to hypothesize that the dermal denticles referred to the genus Petrodus actually belonged to Listracanthus, whether as a different scale type on the body or as a distinct species from the usual Listracanthus. However, he also closed out his discussion by suggesting it could very well be that Petrodus of different regions were their own unique animals. Listracanthus spinatus, 1896. In 1896, British paleontologist, director of the Bristol Museum and Art Gallery for nearly 20 years, and authority on fossil insects, Herbert Bolton, published a paper on fossil spines found in English coal measures that seemed to belong to Listracanthus. The largest of the two specimens Bolton described was found by him amongst the geological collections of the Royal Museum, Peel Park, Salford, when he was arranging specimens. Although unlabeled, it fortunately turned out that the spine was in a broken piece of ironstone nodule and is associated with Goniatites listeri, Goniatites atratus, Aviculopectin, Papyraceus, and numerous small ostracods. Ironstone nodules, like this, are restricted in the Lancashire coalfield to the roof of the bullion or upper foot mine of the lower coal measures, so he was able to determine exactly where the fossil came from. The second and smaller specimen was the property of Robert Cairns of Ashton-under-Lyne and was obtained by him from the marine band of the middle coal measures in the River Tame at Dukenfield. It is enclosed in a nodule of earthy ironstone and is unaccompanied by other fossils. Bolton wrote that he had remembered finding a third specimen a decade before his paper in the shales overlying the bullion coal of the lower coal measures of the backup, but it had been lost. The specimens he described contained just enough differences for him to describe it as a new species, Listracanthus spinatus. Listracanthus eliassi, 1938. Jumping ahead a few decades, we will find the next species described by Claude W. Hibbard in the University of Kansas Science Bulletin's 25th volume. Hibbard notes that he had found 3 spine fossils in the collections of the Museum of Vertebrate Paleontology at the University of Kansas that had been collected by Professor M.K. Elias from a concretion a few feet above the Elmo Coal in the Cedar Vale Shale, Wabansi Group, Virgil series of the Middle Pennsylvanian. Hibbard decided to name these fossils as a new species, Listracanthus eliassi. According to Hibbard, Listracanthus eliassi may be distinguished from the other species by its small size and the fact that the teeth are nearly missing on the convex surface and confined only to the tip of the spine. Though Listracanthus has been found in many localities in Europe, it is one of the rarer forms found in the Pennsylvanian of North America, being known only from the coal measure of Ohio and Illinois, also from a single locality in Andrew County, Missouri, in the Cherokee Shale just overlying the Springfield coal. Listracanthus woltersii, 1949. Apparently, paleontologist Wolfgang Schmidt named another species, Listracanthus woltersii, in 1949. After a long time searching for the citation, I was able to find his paper, but only a preview of the paper as an abstract, and the whole thing is in German. I ain't gonna read that, nor is it actually entirely relevant considering where we will be going in the story of Listracanthus, so onwards. Listracanthus pectinatus, 2006. Now we jump a whole 50 years into the future to find another publication about the feathered sharky scales. This time, the paper is by Raoul Mutter and Andrew Newman, and published in Acta Paleontologica Polonica. The end of the Permian period, about 251 million years ago, saw the most achingly devastating mass extinction in the entirety of Earth's long history. Life took a bit to get back on its feet in the preceding Triassic period, but it did it, somehow. As such, it's one of the most often studied transitions. How did anything survive? That has led to an increase in research on rock layers that border the transition, leading to a renewed interest in the lower Triassic fish assemblage from the Vega Froso siltstone member of the Sulphur Mountain Formation in the vicinity of Fossil Fish Lake in British Columbia, Canada. These fish deposits show an interesting mesh of Paleozoic and Mesozoic fish faunas. Mutter and Newman overviewed the section and the fossil content of the lowermost 85 meters of the Triassic in this area, with special reference to the occurrence of the genus Listracanthus. Samples from various other localities in Western Canada with exposed equivalent strata were included in this morpho-histological study. So, at this point, Listracanthus, whatever it really is based off of some super bizarre bits of sharky tooth scales littered across the fossil record from the Upper Carboniferous of Vermilion County, Springfield, and Carlinsville, Illinois, Montezuma, Coal Measures, Indiana, Nodaway County, Missouri, and possibly from the Manzanita Mountains of New Mexico. It's also been found in the Pennsylvanian Lake Neosho shale member of the Altamont limestone in southeastern Kansas, Upper Carboniferous of Castillao near Mons, Belgium, Upper Carboniferous of Ohio, various Westphalian coal measure sites, the clay gross horizon of the Jockey House drilling in Nottinghamshire, and in various German coal sites. The diagnosis of the genus Listracanthus has been problematic since its publication through extension and inclusion of remains more or less ambiguously associated with these denticles. That seems to be the case for a ton of fossil organisms described before the 1900s, but this is especially the case for superfragmentary critters known from just bits and pieces of hard parts. Listracanthus-like spines from Wapiti Lake were briefly described in 1976. On the basis of more and better preserved specimens, the 2006 Mutter and Newman team redescribed these enigmatic chondrichthyan remains as dermal denticles of a new species that they named Listracanthus pectinatus. Although it's true that these remains of Listracanthus are not found in direct association with any of the other fish remains, their stratigraphic occurrence clearly exceeds the single siltstone lens above the main fish layer noted by paleontologists Schaefer and Mangus in 1976. The remains of Listracanthus are represented by two distinctive size classes: large denticles measuring approximately 60 millimeters in length, denticle type 1, and small denticles measuring approximately 2 millimeters in length, type 2. The denticles are found in accumulations or at least partially in relation to each other. Many less well-preserved specimens were not initially collected, however, due to the weight limit for transportation of fossils. The team figured the layers from which their Listracanthus fossils were coming out of dates to the early Triassic based on the vast amounts of other fossil animals they found in the same layers, as well as the layers directly above and below the layers that held the Listracanthus fossils. They used those fossils as biomarkers for time. As with all previous descriptions of Listracanthus, none of the studied specimens allow reconstruction of the original position of denticles in relation to each other, but the evidence strongly suggests that Listracanthus pectinatus was a large animal, up to several meters long, with most body areas largely covered with small and distinctly arranged denticles. What the hell is it? What did Mutter and Newman figure for the phylogenetic or taxonomic placement of old Listracanthus? Well, based on the 1976 work of Schaefer and Mangus, Listracanthus is a chondrichthyon. That's been the traditional identification, simply a type of cartilaginous fish without certain affinities to any other known ones. The identification of Listracanthus as a rubber-spined chondrichthyon is backed up by the phosphatic nature of the many hundreds of denticles found. The superficial similarity in the structure of these denticles to the denticles of other sharks, and the absence of any form of hard calcified skeleton. However, no enameloid appears to be present on the denticles. Enameloid is an enamel-like tissue found in many fish and is the primary outer layer of shark dermal denticles. A positioning of Listracanthus among the petalodontid sharks has been suggested before, but this is not supported by any remains examined according to Mutter and Newman. According to Mutter and Newman, in 1949, von Wolfgang Schmidt described the scales found on the same slab as his single large denticle that he named Listracanthus woltersi. From Schmidt's description and illustrations, it's not clear whether these remains represent badly preserved, inarticulate brachiopods, aberrant scales, or may indeed be tiny teeth associated with the Listracanthus denticle. To date, there is no unequivocal report of associated teeth described, hinting at a specific relationship of Listracanthus with other chondrichthyons. In contrast, the unique morphohistology of denticles suggests a rather isolated and unique position in the chondrichthyon group. Acanthorhacus enters the picture. Okay, alrighty, all good. We are now in 2014 with the Listracanthus story. Listracanthus is now thought of more as a form taxon than anything stable. A form taxon is a collection of organisms that is given formal recognition at some rank with a taxonomic name, but which is known to be a grouping based on similar morphological characteristics rather than more extensive biological similarity. This is good, everything is fine. By 2014, the critter is known from the Carboniferous to the Triassic of Illinois, Ohio, Indiana, Missouri, and Kansas. While in Europe, the genus has been reported from the Carboniferous of England, Scotland, Belgium, Germany, and the Czech Republic. In Asia, Listracanthus has been reported from the Carboniferous of northern China and also from the Permian of the Ural region of Russia. Listracanthus has also been considered present in the Triassic of Canada, where its occurrence has been considered a part of the so-called Lilliputian recovery fauna after the Permian mass extinction event. In 2014, the infamous David Martill and not infamous Peter Del Strother and Florence Gallion published a paper in the Cambridge University Press in which they describe a new specimen of elasmobranch with associated spines and denticles that resemble Listracanthus, but with a few differences. The new specimen was recovered from the east side of an old colliery spoil dump on Todmorden Moor, Calderdale District, West Yorkshire. It appears to be located close to the boundary between the Millstone Grit and the lower coal measures. The team threw these specimens in various acid baths to eat away the rock around the spines. They threw these spines under a scanning electron microscope to get clear and perfect images of the little buggers. They also did some histology of these things by cutting through the rock and placing the slices on glass slides to illuminate under a microscope. All of this showed that all of the Listracanthus spines are hollow. The new specimens described in the paper are identical to known Listracanthus spines, except that on the sides of the spine, where the lateral ridges are, the new specimens have irregular spines erupting from the ridges. There are also a wider variety of dermal denticles associated with the new find, with some looking like little knots of spines rather than a single big feathery spine. To this end, the team was able to redefine the features that distinguish the various Listracanthus species and named an entirely new genus and species, Acanthorhacus spinatus. This new name is composed of the Greek akanthos, meaning spine, and the Greek rhakis, meaning spine, and the Greek spinatus, meaning spine. Yeah, I'm not kidding you. The spiny spine spine. I suppose that makes sense with the nature of this critter's extra spiny spines. The spinatus species name should sound familiar to you. This is because the 2014 team synonymized the Listracanthus spinatus species erected by Bolton in 1896 with this new genus. The 2014 team was also unable to find enough evidence for all of the various species erected over the last 150 years to get the synonymy treatment. They were simply not different enough in the ways that count to fully divide them up into a bajillion species. So, they sunk Listracanthus hilderthi and Eliasii, but probably also Waltersi and Bayrichi. But there are no figures for these two, so the team couldn't definitively synonymize them. That means that the only valid species, according to the 2014 team, are Listracanthus hystrix and pectinatus. So, now there is at least something of a classification for these creatures. They are the Listracanthids, a family floating around in the Chondrichthian group with no tether. The lost specimen. The problem with Listracanthus is that, aside from the brush-like spines recovered, its appearance is nearly unknown. This makes classifying this animal problematic at best, though most paleontologists are at least comfortable in placing Listracanthus among the Chondrichthians, or cartilaginous fish. This does not necessarily mean that Listracanthus looked anything like a modern shark. Early sharks frequently had a more eel-like appearance, such as Orthocanthus, or had some incredibly unique structures attached to them. Almost all reconstructions of Listracanthus show an elongate, eel-like animal with a bushy spine border on its back. Author and illustrator Ray Troll mentions in his book, Sharkabet, that past chairman of the geology department at the Field Museum of Natural History, Rainer Zangirl, is supposed to have discovered a full-body fossil with brush-like spines. It's possible that this was a full Listracanthus or Listracanthus-like animal. Unfortunately, the specimen dried out and crumbled to dust before it could be preserved. Dr. Zangirl described it as an eel-like animal with a brush border of spines. As such, according to Zangirl's account, Troll reconstructs Listracanthus as resembling a tremendous, fiercely bristled frill shark. It has therefore become a paleoart meme, with everyone copying this sort of hypothetical shark. Problem is that since there are no figures and no photos of this full-body specimen, the appearance of it described by Zangirl and Troll is entirely scientifically irrelevant, as tantalizing as it is. It's possible that the eel-like creature was not a Listracanthus, or is what one of the species looked like, but not all of them, or maybe that it was an Acanthorhynchus, but not a Listracanthus. Point is that it's a total non-starter. Maybe Listracanthus and Acanthorhynchus were just big ol' eel sharks, but maybe they were more like the traditional shark body plan, or something else entirely. It cannot even be known or hypothesized what it was they ate or who ate them, as no teeth nor jaws have been found, nor have any spines been found in the stomachs of other predators. One possible body fossil specimen may have been found by Fossilide 6S, a member of the Fossil Forum. As he wrote in 2018,
I'm happy to announce I possibly found the most complete Listracanthus to date, and we may finally get a proper ID for this strange creature. I thought this was a regurgitation, but while prepping I believe I ran into cartilage, so I will stop prepping and give this to a professional, or at least let someone with more experience look at this. Unfortunately, the rest is in a giant wall of black shale that I won't be able to get back to until next spring-summer. The denticles are up to 6 mm thick and associated with smaller denticles. I will get more pictures under a scope when I get a chance. God willing, I will recover the rest of this creature in 2019. Happy hunting.
Unfortunately, absolutely no updates have been made since the original post, so this specimen is another entire unknown. And with that, we end our little foray into the life and time of something. Well, at least something with the name Listracanthus. I hope that someday a good fossil is found of this critter, and it shows it to be something entirely different than people thought it would be. I love Dinochyris situations. For more interesting stories about nature, the history of life, or what goes bump in the night, subscribe, like this video, drop a comment in the comment section below, and hit the bell icon to stay in the know with everything Edge. Thanks for watching.